Okay, so I just want to spend some time going over your pink sheet, making sure you have those answers filled in. When we're talking about graphing rational functions are going to be where we have a ratio in our function, some kind of numerator and denominator. We're going to remember to factor that numerator and denominator, particularly because the denominator is going to tell us about these vertical asymptotes, and they're going to tell us where we have an output equal to 0. And that's going to give it undefined, and that's what we can't have. Our vertical asymptotes, we're going to find them by setting our denominator equal to 0 and solving. That's going to be where we end up with that undefined value. When you look at the calculator, that's frequently where you see an error in our y and our x value. What x value gives you that error as an output. Our horizontal asymptotes are a little bit harder to find. There's actually 3 different scenarios that could happen. And I know we've talked a lot about this A over B, but it's actually more about the power of the x's. If there are more x's in the denominator of the fraction, you're always going to have y is equal to 0 as your horizontal asymptote. If the degrees of the numerator and denominator are the same, then you're going to use that fraction, a over b. If the degrees of your numerator are the same, let's say I had an x squared in my numerator, then there's going to be no horizontal asymptote. And that's a more complicated idea that you'll talk about more next year in pre-calculus. Make sure you always remember to write your horizontal asymptote as y is equal to and your vertical asymptote as x is equal to. Now for your x-intercepts, when we're talking about this function here, we want to make sure we understand it doesn't matter whatever's in the denominator, because with our x-intercept we're looking for an output equal to 0, and that happens when this numerator has a value equal to 0. So we're going to set that numerator equal to 0 and go ahead and solve. And that'll give you where we get an output equal to 0, and that's going to be where you put that x in. Your y-intercept is easiest if you find it by looking at your table of values and remember where 0 goes in, whatever that output is going to be. These additional points that you find, it's smart if you look on the left and right of each of your axes. So I want to say, let's say that we had a coordinate plane that looks like this. Let's say we had some vertical asymptotes that looked, and we talked about having more than one possible. It's smart to look at whether or not your values are positive or negative, because sometimes they can give you an interesting view of where your graph sits. Finding those points to each side of the asymptote and then in the middle lets you know, looking at that positive and negative output. For your domain, I want you to think about all the x values that hop over the asymptotes. And for your range, same thing too. What's interesting about the range is your horizontal asymptote can actually be a point, and we saw that in one of our ones in the notes. So you're going to look from negative infinity to positive infinity, and you're going to look at which values don't have points. And those are often the same as the asymptote value, but not always. Our end behavior, as x approaches negative and positive infinity, is always going to go by our horizontal asymptote.